I just recently got back from being on parental leave. I just adopted my son. We adopted him in South Africa. So I had some thoughts. This is kind of like a talk that I developed when I was trying to think about everything but feeding him SpaghettiOs and, if he's going to nap or whatever. So we needed a little extra time to round off until it was time for everything to be ready. And I had this opportunity, and I told Katie, I was like, I have a talk. So I promise this won't be very long. But I think it's kind of an important thing to kind of cap off the day. I have a clicker, too. Maybe. Valkey makes you a better developer. This talk, I was looking at it, and it's a little bit of a reach, but I promise it goes somewhere. So I've been using Redis since 2012, and I think that maybe, has anybody been using it that long? Me? A couple people? Okay. And it also goes to show there's people who are way better at it than me, so I'm just not very good in actually learning it in the amount of time that I've used it. But I think I do have kind of an interesting kind of concept of it. But I want to rewind a little bit and talk about how this talk came up. Basically, I had very little time to think and mental energy to think about doing anything else during this time. And so I was reading, like, when he was taking a nap, or I was, drained at the end of the day. I was trying to find, like, some bite-sized things to get my mind thinking about anything else. And I ran across the article, and I'll tell you about this article in just a moment, but this talk is largely based on an article I read and how it kind of relates to Valkey. And it talks about things that make you a better developer, make you write better software. And so one of the things it talked about is, and I'll show you the article in a minute, it's like the different ways you think about things. But I started thinking about, like, when you're building applications, you're building software, you have various different pieces that you look at. And some of those things make you a better developer. Some of the things have a neutral effect, and some of the things have kind of a negative effect. So this is my kind of way I conceptualized it. First thing I want to talk about is just, when you're putting things together, you use all these different tools, and all the different tools have different effects on it. And so the one I want to talk about first is kind of like, things that kind of have a neutral effect. And that's what I'm representing by the little brain with the yellow 0 next to it. Like, it doesn't have anything. It just kind of helps, And I kind of came up with, like, build tools. Like, build tools don't make you a better developer, but they actually kind of just, like, make your life a little easier. It's automation, right? Fine. That doesn't really affect anything. I can't say that I'm better for using make or whatever, right? And then I thought there are definitely things that make you make better software. And I'm representing that by the green plus next to the brain, if you've been following along. And when I think about that, I think about things like code quality tools. Like, if you're doing something that, like, maybe a linter, if you're using something that maybe, for me, when I first started writing software, I didn't have, like, a proper editor, and I started moving to things that had, like, syntax highlighting, and I suddenly saw all the horrible inconsistencies that I had, and just, like, it made a world of difference. It made me a better software developer. There's just a lot of things like that, formatters, things like that. These do make you write better software. They find subtle bugs and that sort of thing. And then we move into libraries, and I put libraries in kind of the mixed category. There are definitely libraries that you can use that make you a better developer. How many people have heard, oh, this is a great cryptography library, I wrote it myself, right? Like, that should be something you'd run really far away from. You should leave that to the experts. So by using someone else's cryptography library, you're a better developer, you're writing better software. But if you actually take a look at many other libraries, they may just obscure an abstraction that doesn't allow you to understand the software you're writing. Like, that kind of makes you a worse developer, right? You've written something like this, maybe, like, a key idea is like a really bad ORM, right? That you have used all this stuff and it spits out garbage SQL and you have no idea how to fix it. I was talking to somebody in this conference about Cassandra, and he was talking about how Cassandra is a great piece of software because it will continue to run even when it's in a semi-broken state for years until it becomes so degraded that you can't do anything about it, but it was a mistake you made 2 years ago, and now you have this giant mess to clean up, right? Using that in your software kind of doesn't really help you. So I'm not picking on Cassandra entirely for the rest of the talk. That's my only comment on it. But I think that's when we get into databases, and I think sometimes databases have this effect, right? But I think Valkey, and I consider Valkey a database, which is slightly controversial, but I think Valkey actually goes into the green category, and I'll tell you why. The article that I read, and I'll just kind of fast forward to this. This is the article. Let's see. Good programmers worry about data structures and their relationships. It was in Engineering Codex. The URL's at the bottom of the screen. It's like kind of a Substack thing. It was a bite-sized piece of content, and it really got me thinking about some things. But I want to extract a couple quotes from it. Let's see here. So there's a quote. It's from Linus Torvalds, creator of Linux, but in this case, we're talking about Git. He once said, "Bad programmers worry about the code. Good programmers worry about the data structures and their relationship." Right? Like, I think that's a really cool quote. And with that, he was talking about Git and how Git is actually a relatively simple program in that the data structures are where most of the complexity lies, and the actual code is quite simple. There's another book in which I've only read excerpts of this book. Actually ordered it and it came while I was here. The Art of Unix Programming. There's a quote in this that says, "Where you see a choice between complexity in the data structures and complexity in the code, choose the former. More involving in design, you should actively seek ways to shift complexity from code to data." And I think you could misunderstand this a little bit, but what I think it's really saying here is that when you're getting to complex code, you've probably made a mistake in how you've modeled your data effectively. And I think that's actually a really important piece of information. And how does this all relate to Valkey? When you really start thinking about Valkey, and this is the effect it had on me many, many years ago, over a decade ago, it really forced me to think about all the code that I was writing in more fundamental data structures. And I'll give you an example of this later, but when you start thinking about these pieces, if you want to optimize your code, you kind of have to start thinking about it and how Valkey would be thinking about it. You don't have the opportunity to kind of like just say, database, take care of this for me, right? And it does whatever it wants to. And I'll give you kind of like one of the things I always find interesting is like the origin stories for people. Like, why did you get where you are and why are you here involved in this community? And for me, one of the first projects I worked on with Valkey, well, Redis back in the day, was a very complex project. It started out as a proof of concept that was written in like a LAMP stack, which is popular at the time. And it was horrible and kind of barely worked. And I did a review with some of my stakeholders and they said, well, it needs to be faster, and it needed quite a few other things. So it was only a proof of concept. And then I moved into actually writing the code. And I said, well, okay, I need to make it faster. So I don't know where I need to optimize, but I know I probably will use Redis at the time. And I started writing my code using kind of these more fundamental data structures and really modeling the data so it could be used in Redis. And then I selectively changed some things into Redis. And I went to a review meeting with my stakeholder, and I had this one comment about something that really affected me. I still remember this. Could you make it slower? Which was kind of a cool comment, and I'll tell you about what happened. Basically, it was kind of a type-ahead situation where you typed a query at the top of the screen and it returned results at the bottom. And when it did that, people were incredulous that all the results were being updated. So like you just see the first couple of results, and when you typed ahead, you'd see the other things come along. And we actually had to put in visual weights, like waiting time, like a little spinning disk, to show people that something was happening, even though we've retrieved the data. And I contribute that to basically writing everything with these fundamental data structures and being able to optimize it in the right places. It really made my software better. The software was more readable, the software was more maintainable, and the software was quite a bit more performance. So like I think this actually was because I had that forcing function. So I think it helps you write better software. But I do think as well, software is more than just algorithm syntax. So there's examples in Valkey which help you understand writing good software from the beginning. So when I think about Valkey today, I think these are different than what was in Redis. Three kind of main areas that are great examples of how to write good software. And this is not just applying to open source software, right? I think the openness that's in the project is really refreshing for people. Like, I was talking to people at this event, and those who didn't know about it, by the way, the majority of people I talked to at this event already knew about Valkey. So it wasn't like, do you know about Valkey? And they said, well, of course I do, right? That was a very common response. But what was really interesting is people thought we were a company. Like, they thought it was like some sort of startup or something when I talked about it. But they were really appreciative when we said, well, no, there's no surprises, there's no upsell, there's no tantalizing feature behind some sort of paywall. It is what it is. And I think that transparency is really important when you're developing software, even if it's open or not. Just being completely transparent about what you're able to offer, and people will appreciate the software you're writing. The collaboration that comes in this project is really something to look up to. No one company controls the project. The biggest contributors sometimes are people that are not involved every day. I was talking to Madeline early on in the project, and we had somebody, I was looking at the GitHub contribution graph, and it was somebody that wasn't involved in any of the organizations that were really involved. It was a gentleman from, I think, Vietnam that had contributed tons of stuff to the software. And it didn't have to come from anybody. These contributions came from places we wouldn't expect. And I think that's what you're building software in general. Like, sometimes the contributions or the things that make the biggest impact in the software come from places that you wouldn't expect. And then finally, the collective problem solving that we see in this. I think it's really fascinating. It could be a great kind of case study in how problems are solved by looking at the GitHub issues and Valkey in these last few months. So the collective problem solving here really does show the way that solutions aren't owned by one person and aren't proprietary. They come from a variety of sources. So I think that's really a few interesting points that help you kind of get to there. And the other thing I want to talk a little bit about, and this is calling back to a couple things you may have heard about today, is that this is a new project with old problems. And that sounds kind of negative, right? It's not at all, in fact. I think it's a big advantage. If you take a look at this, if you look at, for example, Dimitri and I have talked extensively this week about all the ways he's trying to solve the variety of problems he has. And he's trying to solve them, by and large, with modules, right? And I think that actually shows kind of an amazing maturity in how the problem would be solved. If this was a brand new project, we wouldn't have somebody with the expertise and knowing about the module API that would be solving problems in that way. So we have this advantage of people who have been with the project for a long, long time, but now have the ability to, have an open slate to implement these new ways of doing things. So it's very kind of Valkey idiomatic. You wouldn't get it with a new project. And then the other thing that I saw and kind of appreciate more during this last conference was hearing more about Glide. Does everybody know what Glide is? Does anybody? Most people know Glide. Bar knows about Glide. Yeah. Glide is really interesting because the thing about it to me is it's a classic problem that like a lot of projects face, right? Like every lib and every library in every different language kind of like does things in a slightly different way, and how do you centralize that without recreating everything in every different language? And it kind of solves it by having Rust as kind of at its core one implementation, and then kind of shells that in other libraries or languages that implement the final library. And I don't think that you would see many, brand new projects that would solve this problem this way, because it's actually a lot of work and it's a pretty sophisticated way of solving the problem. They would probably go and try to get it done as, simple as possible without looking at the bigger problem. And the bigger problem wouldn't reveal itself unless it was a project that had old problems. So I think when I think about this from the concept of the original, thesis of this talk, is that I think that you make better software by looking at all these really mature and solutions and best practices that people are using around the project. And you see that there's a lot of things that you can look at and go, okay, these are really good examples for people writing software. So that was just a few things that I wanted to talk about, and talk a little bit about why Valkey is a really good example project for people who are trying to understand how to write good software, and also using Valkey itself would make you a better software developer just by forcing you to think about things in a very different way. So that's all I really want to talk about today. I hope this kind of capped off the day, brought a few things together, and now I think we can go drink. Does that sound good, everybody? Are we good? Are we good, Katie?